Hello, hello everyone. Welcome back to my channel. I hope everyone is doing great. My name is Ravi Teja. Let's solve today's Leetcode problem 110 balanced binary tree. A given a binary tree, determine if it's height balanced. Okay, what does mean by height balanced? A height balanced binary tree is a binary tree in which depth of two subtrees of every node never differs more than one. Okay, so let's look at this example. Okay, so if you see this node has left as null or right as null, let's say depth of this specific node is 1, so this is also having a depth of 1, so this node will have a depth of 1 plus 1, which will be 2. So this entire subtree is, the root is at a depth of 2, this is a depth of 1. If you see the difference between these two, this is a depth of 1 and this is a depth of 2, so this is allowed. Okay, so I will say the depth of this node is basically the maximum of these two plus 1, which is the depth of this node is basically 2 plus 1, which is 3. So the depth of the entire tree is 3. Okay, at any given point, if you found the difference between both the trees, if the difference between the depth of left tree and the right tree, if it is greater than 1, then we will return some maximum value to identify whether it is unbalanced. Okay, so let me show you the code. It is pretty simple. I've just written in the recursive way. I've written a function called depth, which will take a root and which will return me an integer value. It will return an actual value which is less than or equal to integer max when it is a valid depth, or else it will return max value when height is not balanced. Okay, so first I will recursively get height of the depth of the left subtree, and I will recursively get the depth of the right subtree. If any one of it is returning me an integer dot max value, that means the difference between that means the left subtree or right subtree, one of it is not height balanced. Okay, if any one of the subtree is not height balanced, the overall tree will also be not a height balanced, so then I'm returning it integer or max value. Or else if left and right are equal, that means both the depths of both the subtrees has equal depth, that means my root will have a depth of 1 plus height. Or else if the difference between left and right is equal to 1, okay, then my answer will be 1 plus max of left of right. You can actually club these two and you can simply check if absolute difference between these two, if it is less than or equal to 0, then you can take 1 plus max of left and right. Okay, if the difference is not within 1, then means that the current root is not height balanced, then I will return integer dot max value. Okay, in the end, if my root has a depth which is not equal to integer dot max value, that means it is height balanced, or else it is not an height balance. Let's try to submit this. As you can see, all the base test cases are passed, and let's also submit it. As you can see, all the test cases were all passed, and it's pretty efficient solution. It has beaten 100% of the solutions. Okay, before jumping dive into analysis, time complexity and space complexity analysis, I highly recommend you to subscribe to my coding channel. Okay, the reason being, you won't be missing the content which I will be posting on daily basis. Let's try to upskill ourselves on daily basis togetherly. Okay, so let's go back to the code and see what is the time complexity. Okay, if you see, we are processing the left subtree and right subtree, and we are visiting each and every node in the tree at least once. Okay, we are visiting all the nodes in the tree once. Okay, so the overall time complexity will be big of n, where n is the number of nodes in the tree. Okay, what will be the space complexity? If you see our recursive relation, at max it will go to the height of the tree, where it will take a depth. Okay, our recursive stack will go all the way up to the height of the tree. Okay, so the space complexity will be big O of h, where h is the height of the tree, and the time complexity is big O of n, where n is the number of nodes in the tree. Okay, that's all about this problem. If you like the explanation, hit the like button, hit the subscribe button, and share your valuable feedback in the comment section. Thank you.